Okay, so this is a devlog to go over two projects that I've been working on the last couple of months. These two projects are called BOP, which is this Git repo here, and elevon, which is this Git repo here. They are both pure data projects, sets of pure data abstractions that are designed to create rich musical works that respond to multiple data inputs, and being able to allowing a composer to structure music against these various data inputs to solve a couple of challenges that I've come up against attempting to create this kind of work. So I'm going to go over what these two libraries of abstractions do and how they interact. This is going to be sort of cursory, and it's also subject to change. These are they're both at a very good working stage, but they're likely to change quite significantly over the next weeks and months. I'm recording this Friday, the 23rd of July at 10:51 and 35 seconds. So the first suite I'll look at is BOP. BOP is designed as a set of abstractions for creating music. So here we have, and it's designed to be at sort of a level of abstraction similar to a guitar pedal. So we have instruments with parameters that you can control. We have some audio effects. We have ways of generating notes. We have ways of processing those notes, and then we have ways of creating modulation data for changing some of the parameters of the objects, and some utilities for routing audio around the place, as well as a master transport, which will keep everything in sync, and then some ways to pull time data out of our master transport. At the moment, the instruments that are included are a bop.casio, so a Casio-like synthesizer, a sampler, a more general analog style synthesizer, a glockenspiel, a harp, a marimba, and a Rhodes. And these are actually using quite a few of some abstractions created by Mike Morenso, PD-MKMR, who made some absolutely wonderful pure data abstractions that I'm leaning on quite heavily. So I'll quickly go over how BOP sort of slots together, and then I'll look at how it works. Then I'll look at elevon, and then look at how these two things work together. So this is a simple BOP session or patch. I have three objects. I have a bop Casio, a bop reverb, and the bop master. And there are 4 patch chords running between each of them. So what I've done is I've adopted the convention set out by Aurac, which is another a pure data modular synthesizer setup that itself is a remarkable project, but the developer of Aurac settled on this particular convention for creating modules, which seem to be very flexible. And the advantage of me adopting the same convention means that, in theory, it should be quite easy to port all of the Aurac modules into BOP and port all of the BOP modules into Aurac. So we're in happy open source land here, so trying to make things as easy to port across and work together is a good goal, I figured. So the inputs and outputs run left to right. They are audio left, audio right, MIDI notes, and then control messages. So here I have a Casio. It's sending out audio left and right. It's then sending out MIDI messages, and it's sending out control messages. And all of the modules will forward any message it receives up the top. It'll do whatever it needs to do with that message, and it will forward them down to the next module. So you can send messages down an entire chain of bot modules. And what ends up happening is you create these sort of columns, and you're passing control and note data and audio data through these columns. That seems to be the way that this has ended up working. So here I have bot, a bot.casio. I'm sending some notes into it. And we can change some of the parameters as well. For controlling parameters, for example, automating them, we can just send a message that starts with the label of the parameter that you want to change. So here I can hook up a number box to the filter, and the fourth inlet is the parameter inlet, and then I can automate the filter. And because these pass messages down, if I was to instead send the message, for example, damping, I'm now controlling the damping level of the reverb from up here. This ends up being really quite flexible, pretty quirky, but also quite flexible. So that's generally how Bop is working. There's a demo. This is a demo Bop set that is in the repo. This is a demo number 2, which isn't playing for some reason. I've muted it. So this demonstrates some sequences here. There's a bot.euclidean sequencer, some sends and receives that allow you to route all of these bot messages very flexibly, and various levels of processing, things like that. So that is bot. Bot itself is quite effective at building little musical scenes, generative musical pieces that perhaps are responding to data or perhaps are playable. It's really intended for composition more than performance, but works quite well as a performance tool as well. But as part of my PhD research, I'm particularly interested in creating musical works that respond to many data points, and how to compose against these data points, how to arrange music to respond to all of these data points, going beyond what might be the sort of traditional approach of, for example, parameter mapping, where you might have an Ableton set, you might have, MIDI controller data coming in. You can have gazillions of knobs, but it's difficult to create a work that branches in a way that every single knob has a really significant impact on the composition. So if we consider something like adaptive music in video games, you might have an enemy, a big boss, and you're walking through a field and you're walking towards the boss, and the music might change in relation to how far you are away from the boss. So as you get closer to the boss, the music might become more tense to give you sort of cues, create a sense of excitement about what is about to happen. But you might also want the music to respond to something like the health of the player. And what happens then is, you might want something that is, again, building tension when your character is low in health, or be grandiose and heroic when your character is high in health. But of course, then you end up with a situation where you need to make a set of changes in response to the boss, make a set of changes in response to the health, and you end up with this two-dimensional compositional space. And so that's, compositionally challenging, but not unsurmountable. The problem comes when, say, you want to introduce another element. So maybe you drink a particular potion and now you have a particular power and you want the music to respond to that. Well, now you need to create different compositions for each potion that each respond to the health of the player and the distance to the boss. And so this becomes quite a difficult compositional challenge as to how you structure music to respond to all of these data points. Personally, I'm quite interested in working with positional and motion data to create musical works that respond to how you're moving through space, where you're located, your orientation, these sorts of things, and creating dynamic compositions that respond to your motion in the world. And so to manage this structuring problem, this musical arrangement problem, I have a separate suite called elevon. So elevon is this repo here. It's a little image sort of outlining what it does. Elevon, this part of the research is quite a bit more opaque and quite a bit more conceptual. So one of the challenges with this is making it easy to use. And the goal is sort of to be able to create a framework for composers to be able to conceive of working in these multi-dimensional compositional spaces. But in order to do that, I need to solve a bunch of problems. And so at the moment, it's pretty and quite nice to use, but it does have quite a high conceptual barrier. So I'm just going to touch on it briefly here, and if you want more detail, I'll definitely be providing more details as I go and as some of these ideas get ironed out and smoothed out, and I have a better way of presenting them. So elevon. Oh no, I lost PD. There we go. So this is elevon. Elevon, for the most part, consists of two abstractions. One is called the hyperstave. This is the hyperstave here, and one is called the stave. And the hyperstave resembles an Ableton clip slot, and the conception of a hyperstave is that it arranges similar musical elements along a single axis. So this could be, in the example of the piece of adaptive music, your distance to the boss. And so each of these clips, staves, would have a different piece of music in them that each correspond to a particular distance to the boss. And as your distance changes, the different piece of music would play. And of course, you need to manage the transitions between these different related pieces of music, and some might loop, some might do whatever. Elevon doesn't handle any of that. That's all done manually, but it does give you the tools to structure these pieces, these musical components together. So to create a hyperstave with elevon in your project path, I like to put the elevon folder in the project folder and then declare it. That lets you pull in the whole Git repo and just place it. I normally place it side by side with bop, so I can run declare path elevon, bring in the elevon library, and then to create a new hyperstave, you say lvn.hyperstave, and then you say how many staves you want within that hyperstave. So let's make one with 16. And there's a hyperstave with 16 staves, dynamically created. That's an axis that we can work with. The other component of elevon is the stave, and this simply breaks out each stave within a hyperstave and then gives us information about the current state of that stave and allows us to send information up and down these nested hierarchies that we can create. So here is the first stave. You can see that it is red. It's the first stave, and we simply route out. We use a route object to route out the various staves. And as I move the hue or the axis of the particular hyperstave, you can see the stave becomes highlighted when it's active, and I'm getting information coming out of the right outlet. And that information is the relative position, so that is the relative position of the hue to my hyperstave. So there's 0, and as you get closer, as you come back to the hyperstave, we get so the reason I'm using hue is because it cycles. It's circular, and this allows you to create essentially loops, which ends up being quite useful when you're creating these hierarchies. So we've got relative position, we've got distance, we've got is the current hyperstave active, and we've got its coordinate in the hierarchy that you end up creating. And then you're also able to control the playhead, you're able to control the little button on it, and you're able to send messages that all get collated and pop out of the right outlet of the parent hyperstave. These are essentially the two objects. So let's have a look at it actually in action. So of course, the hyperstave and the stave themselves don't actually make any sound. They're simply there to help structure compositions. And so this is where you can use the bop modules inside the hyperstaves, and use the bop modules to create your compositions, and use the hyperstave to, or elevon and elevon's hyperstave to structure these compositions. You don't necessarily need to use bop. You could create pure data patches that are doing whatever you want. Bop's simply there to ease that compositional process, so to make it more like composing a piece of music than patching low-level pieces of code together. So, as part of my project, I have this sort of utility module here, which lets me pull in motion data. It's included in the elevon repo at the moment, although I don't expect anyone else to get any utility out of it. And here we have a simple elevon and bop setup. So this component of the patch will be bringing in data externally and basically I'm calculating ground speed. And then I'm using that ground speed as a data point to move through a composition. The ground speed here is being scaled and then is being used to control the hue, which controls that axis of the hyperstave. And so you can see once we get above sort of 6 kilometers an hour, then we click over to the next stave, like so. And the way that I tend to work with these hyperstaves is that I'll embed, or I'll create a subpatch for each stave, and then within that subpatch you can create a composition. So notice I've got still and slow. So still is basically anything below 6 kilometers an hour, and slow is above 6 kilometers an hour. So we'll have a look at still. In here is a fairly messy bop patch. And if we have a look at slow, there's another fairly messy bop patch. But what we can do is we can start bop playing. And so this is the hyperstave as it is still. And then if we transition to slow, so we get over 6 kilometers an hour, then we have a different clip. And these could be completely different pieces of music. In its simplest sense, that's what it's doing. It's switching like you would an Ableton clip. But the power with this particular approach is that inside each of these compositions, that is the still composition and the slow composition, or these staves, you can do anything you want. You know, this doesn't even necessarily need to be music, it could be a sequence of robotic moves or whatever. But the real power is that you can, within each stave, you can embed another hyperstave. So this hyperstave, I'll make a hyperstave here, hyperstave 8. This hyperstave could conceivably be responding to another data point, for example, velocity, acceleration, the battery level of your phone, the temperature, the whatever you want. And then you can have a still composition that responds to a whole bunch of data, and within each of those subcompositions, you can have them responding to other pieces of data. And this way, you can build nested hierarchies that allow you to create very rich, responsive musical works. And I think this solves one of those problems that you get often in patching environments, where you create a little algorithmic composition, and it's this patch, but often these works, often these little compositions, they take a lot of effort to create, but they're also quite static. You end up with a patch that does one thing, and you then need to structure a series of patches to create a richer sort of, in how you might approach, for example, a pop song where you need a bridge, where you're going to need another patch for that, and then you need a way of structuring them either over time or in response to some other non-time data. So that's Bop and elevon in a nutshell. I think it does point to some other problems here, which is when you are creating a musical piece like this, the amount of content that you need to generate is vast and grows exponentially with each data point that you start to incorporate. So my intentions with this project is to err away from completely generative work. I want some compositional control. I want to be able to create music in a similar way, or at least something that is somewhat akin to working in a DAW, or even writing out a score. But in some situations, you just need a way of generating some sort of generative or algorithmic content that will help you sort of fill out that amount of content that you need to create these works. So that is where being able to bring in the coordinates of where your particular stave exists in this nested hierarchy, you can use those coordinates to create generative melodies that are like, okay, I know I'm the third hyperstave in a nested hierarchy of 5, and then you can create an abstraction that sort of generalizes an approach to creating a melody that knows where it is in the hierarchy. So this allows sort of a hybrid approach to composition, where you're able to both explicitly compose things using, for example, MIDI clips, or here I'm just bringing in bop.time and creating really simple sequences. But you can also create generative aspects to the composition that work alongside those explicitly composed pieces. Whew. Okay, so that's Bop and elevon as they are on the 23rd of July 2021.